Hello everyone, welcome to you all. Today I am going to discuss about mirror formula using concave mirror in terms of real image condition. So for our comfortness, I have already made a figure alongside. So let us acquire some information regarding our figure. Here we can see an object AV is placed beyond C, from where a ray AM is being incident upon a mirror. Also we can see this ray AM is being parallel to principal axis XY, so it get reflect back through principal focus. Also we can see another ray AQ is being passed through center of curvature. That means this ray press back through the same path, so the intersection between these two rays gives our image, that is A dash B dash. So from figure we can say that triangle ABC similar to triangle A dash B dash C. Here we can see these two angles are 90 degree, they are equal, both being 90 degree. Also these two angles are equal since they are vertically opposite angle, so we can say that these two triangles are similar to each other. As we know, the ratio of corresponding sides of similar triangle are always equal. We can write AB by A dash B dash is equal to BC by B dash C. Similarly, we can say triangle MNF is similar to triangle A dash B dash F. So here also same condition. Here these two angles are 90 degree. So both being 90 degree, they are equal. Also these two angles are equal, being vertically opposite angle. So we can say that these two triangles are similar to each other. Also we can write MN by A dash B dash is equal to FN by B dash F. So let us consider this equation as equation 1 and this as equation 2. In equation 2, we can say that MN is equal to AB. Here this AB is equal to MN. Hence we can substitute AB in terms of MN. So AB by A dash B dash is equal to FN by B dash F. So here if N is close to P, so in this figure if N is close to P, then we can say that if N is close to P, Fn also can be written as Fv. So the above equation can take the form AB by A dash B dash is equal to Fp by B dash F. So let us consider this as equation 2 dash. So from equation 1 and equation 2 dash, we can write BC by B dash C is equal to Fp by B dash F. Now we have to reduce this all the terms in terms of FUV, that means focal length, image distance and object distance. So let us see, BC can be written as BP minus CP. Also B dash C can be written as CP minus B dash P is equal to, here FP we leave it as FP by, here B dash F can be written as B dash P minus FP. Now so using RP sign convention, that means real positive, we can write BP as object distance, that means U, minus CP is twice of focal length, so we can write it as twice of focal length by CP, it is also twice of focal length, minus B dash P, it is an image distance, so we can write it as V is equal to FP, it is our focal length, we simply write it as F by, here B dash P is our image distance, so we can write V. Also FP, it is our focal length, so we can write minus F. So here we have to do some mathematical calculations, that means we will cross multiply them. We get UV minus UF minus twice FV plus twice F square is equal to, here we get twice F square minus FV. So these two terms are equal, so they cancel out each other. So the remaining term is UV minus UF. So here if this FV comes to LHS, so here minus twice FV plus FV we get minus FV is equal to 0. So here dividing both sides by FUV, we get 1 by F minus 1 by V minus 1 by U is equal to 0. So here we simply divide both sides by FUV. So here we can say that 1 by F is equal to 1 by U plus 1 by V. So simply this is our required mirror formula for concave mirror in terms of real image condition. So thank you.